Let's understand the network attachment. This is again another important point of this unit. Okay, so network attachment, which is one of the most foundational element in a data center design. Okay, network attachment refers to how the servers and client physically and logically connected to the network. So this design decision directly decision and its impact on the performance, redundancy, scalability, security, or storage connectivity. So if the network attachment is poor design, the entire data center performance can be suffer very heavily. So what is a network attachment? So network attachment define how a server connects to the IP network. So every server or client require the hardware components to connect to that particular network. That hardware component is called as a network interface card, and that commonly known as NIC. Okay, so I hope you understand what is the network attachment. So here we have the one hardware component, that is a network interface card, that is commonly known as NIC. Okay, so what is NIC? NIC is the interface between the servers and Ethernet network. It provides several important functions. Okay, like the physical connectivity to the Ethernet networks. Um, like using we can do that using the port, that is RJ45, or the copper ports we generally use, or fiber optic cables. Okay, uh, RJ45 is typically used for copper Ethernet connections, and fiber optic ports are used for the high speed and long distance communications. Okay, then it provides a unique MAC address, that is unique media access control address. So every NIC has the unique media access control, that is a MAC address, and this MAC address generally identifies the device at layer 2, is used for the frame forwarding in a switches, and it ensures the proper delivery of the data within a VLAN. So no two NIC should have the same MAC address. Okay, regarding the speed, supports, what we say that it supports almost the 1 gigabyte, 10 gigabyte, 25 gigabyte, 40 gigabyte, and 100 gigabyte full duplex communication. So in modern data center, 10 gigabytes and above are very common. uh, that higher speed NIC improves the data transfer rate, application performance, and storage access speed. Here we use the full duplex communication. What does that mean? The NIC supports the full duplex communication, means data can be sent and received simultaneously. Data can be sent and received simultaneously. Okay, so this eliminate the collisions and improve the efficiency as compared to the older half duplex systems. Okay, uh, why multiple NIC we requires in a modern data center? So in an older system, servers oftenly had only one NIC, but in modern data centers, servers typically have the multiple NIC. Why? Because the five major reasons. First one is the performance, redundancy, scalability, security, and storage connectivity. Okay, so if we talked about the performance, traffic can be distributed across the multiple NICs using the techniques like the NIC loading, NIC teaming. This increase the bandwidth. Redundancy. So in terms of redundancy, what we can say, if one NIC fail, the second NIC continues to operate, and this generally prevent the downtime. If you talked about the scalability, additional NIC allows the servers to handle the more network traffic and demand increase if in case of demand is increases. Fourth one is the security. We say that the separate NIC can use for the management traffic, application traffic, and storage traffic. So this isolated different types of traffic. Okay. So I hope you understand this network attachment. Okay. Let's see the storage area network. Okay. uh, in this slide we are going to understand the role of the storage area network, that is SAN, and host bus adapter, that is HBAs. So in modern data center, storage connectivity is just as important as network connectivity. So server not only connect to the IP network using the NICs, but they have also the connected to the dedicated storage network. Okay, dedicated storage network. So let's understand what is SAN. We already understand what is SAN, storage area network. uh, how do server connect to SAN? Let's understand that one. Okay, how do that server connects to SAN? So to connect to an IP network, servers use the NIC, that is basically used for that one. But the connect to the fiber channel SAN, servers use a different devices is called as a host based adapter. Okay, host based adapter. So NIC stands. Uh, so NIC generally used for the Ethernet and IP networking, and HBS is used for the fiber channel SAN. Okay. If you ask me what is the SBS, then I will say that it is a specialized hardware that is adapted to install inside the servers. So it performs the three important functions like the connect to server, to the fiber channel switch, enable block level storage access, and provide the high performance and low latencies. Okay, so I hope you understand this slide. Yeah, sorry. uh, Sorry. So why separate storage traffic from the IP address? It keep see uh, why just not you use the Ethernet for the everything? So the answer is the performance and reliability. Okay, storage traffic is really sensitive because it involves the database read write operations, it supports the replications, it supports the clustering. So if storage traffic mix with the normal IP traffic, the congestion may occur and latency may increase and performance may degrade. So by the HBA and separate SAN, the storage traffic is isolated, the network congestion is reduces, and it generally performs the or its perform becomes we can say predictable. So this separation improves the overall data center stability. Okay. Sorry. So uh, now we are going to see the modern network interface card capabilities, its capabilities feature, and understand how this advanced NIS feature improve the server performance in the data centers. So in earlier days, NICs were simple device that only transmit and receive the packets. But in modern data center, NICs are the intelligent devices with the advanced capability that reduce the CPU or workload and improve the efficiency. So let's discuss the key features one by one. So first one is a direct memory access. First one is what? Direct memory access. Um, it is one of the most important feature of the modern NIC. Normally, when the data center arrive at the servers, the CPU would be involved in transferring data from the one NIC to RAM. So this increase the CPU workload. So with direct memory access. The NIC transfers the data directly to the end from the system memory, and the CPU is bypassed during the data movement. So this improves the two major benefits, that reduce the CPU utilization and faster the data transfer. So this is especially important in high traffic environment like the virtualization host and the database servers. Okay. Second feature is interrupt coalescing. Okay. So every time the packet arrive, the NIS generate an interrupt to notify the CPU. So if thousands of packets arrive per second, the CPU may become the overloaded with the interrupts. So interrupt coalescing involves this problem. So not involves solves this problem. So instead of generating the interrupt for every single packet, the NIC groups the multiple packet together and then it sent to the single. It sends as a single interrupt. So this reduces the CPU interrupts and improve the overall server performance. So it is especially useful in the high throughput environment. Next one is jumbo frame supports, that is named 9 KB frame. So in modern NIC, the support jumbo frame which can carry up to the 9 KB of data in a single frame. Why it is beneficial? So more data per packet, fewer packet requires for the same amount of data, and reduce the overhead and lower the CPU processing. Okay. Fourth one is IEEE 8021Q support. In modern NIC supports which enable the VLAN tapping. So this allow a single NIC to connect with the multiple VLANs, carry traffic from the different network segments. Okay, so for example, one physical NIC can be handled uh, which generally manage the traffic, application traffic and storage traffic. So using the VLAN tagging, this improves the flexibility and reduce the need for the multiple physical interfaces. uh, Last one we can say that TCP IP offloading. uh, this task like the checksum offloading, this task is like the checksum calculation, segmentation and packet reassembly. So we can consume the significant CPU power. So modern NIC support the TCP IP offloading. This means this takes these tasks are handled by the NIC hardware instead of the CPU. So as a result, CPU overload are reduced and application performance improve and server efficiency increases. So this is a very useful in high performance environment, such as virtualization, cloud data centers, and all these things. So why these features matters? So all this modern NIC capability help to achieve the high throughput, low latency, reduce the CPU uses, and better scalability. Also, it improves the overall server performance. Okay. Uh, we will cover this server multi-homing in a next upcoming sessions. Okay, that's it for today. Thank you very much.